Hello, STEM geometry students. Sorry I'm absent today, but here's your 7-1 notes recap. So let's recall from the video. We're talking about 3D figures now, right? So let's go ahead and start with prisms. All right, so if we start with a prism, and again, the videos are a little bit longer today because we were trying to really get into, the next, 4 lessons. So a prism is a 3D figure with two congruent bases. So I'm going to use the circular based figures today. So a cylinder is the circular version of a prism. So that means it has two circles, top and bottom, and then it has these heights drawn vertically. Okay. So again, when we talk about a prism's base, we are talking about these guys here and here, right? And they should be congruent. Okay. Now, the first discussion was about cross sections. So there are two types of cross sections that we care about, right? The first one is if we are parallel to the base. Parallel, that's at 11, to the base. So if I take a 2D plane and cut this cylinder sideways, parallel to the base, what's going to happen is it's going to hit this edge here, and it's going to follow that cylinder all around here and around here, and it's going to create another circle, which is the shape of the base. So when you're parallel to the base, right, your cross section is going to be the shape of the base. So these are for our cross sections. So cross sections. So when you are parallel to the base, you are the shape of the base. So I'm going to say the base shape. Now, if you go perpendicular to the base, and let me see if I can do it in green. If I go perpendicular to the base, so in this case going more vertically, you're going to hit the top circular base maybe here and here, the bottom circular base here and here, and you're going to go all the way down that side, all the way down that side, and connect them, and you see that you get this four-sided figure, right? That is going to be a rectangle. For any prism, when you cut the figure perpendicular to the base, you are going to get a rectangular shape. Okay, so that is our prism talk. All right, now let's talk about pyramids. So pyramids only have one base, and they have a point. So a pyramid has one base, and a vertex. That is that top point. Okay. So again, I'm going to draw a circular-based pyramid, which would be a cone. So here's my base, there's my vertex, and then here's the connection of those two. Okay, so again, in this picture, this circle is the base. So now, if I talk about the cross sections, same thing. Cross sections. Okay, so if I'm going to be parallel to the base, then what's going to happen is when I do this, right, I'm going to cut this edge here, and again, I'll follow all the way around this cone like this, and you can see that I get a shape that is similar to the base, right? So it's the base shape, but it's going to be a smaller, similar version. So I'm going to put the little squiggle for similar, right? It'll be a similar version, okay? And now if I go perpendicular to the base of a pyramid, what's going to happen here is typically you go through that top point, and then you hit the bottom base in two places, maybe here and here, and you connect those three dots, right? Three, and hopefully you can see that you get a three-sided figure, which would be a triangle. And again, because the pyramid comes to a point at the top, typically, every time those perpendicular cross sections are going to be triangles. So unfortunately, it's just something you have to kind of memorize, right? Now, the other talk we had was about solids of revolution, okay? There are three solids of revolution that we really care about, solids of revolution. And what this basically is, revolution, is taking a 2D figure, rotating it or revolving it around an axis to create a 3D figure. So we have 3 to talk about. And again, they all involve circles because we're revolving, right? So when you think about this revolution idea, think about a circle. Okay, so if I have an axis like this, right? And I have a rectangle like so. When I revolve this rectangle, what's going to happen is this point is going to go over here, turn, and come back here. This point down here is going to go over here, turn, and come back here. And if I connect those, which is what's going to happen with all these points, hopefully you can see that you get a cylinder. So a rectangle, 2D shape, a rectangle will lead you to a cylinder. Okay, the next one is a triangle. So if I have a axis and I have a triangle, now with the triangle, this point stays put. But now this point right here rotates all the way around, all the way back. We connect it, and now hopefully you can see that there's a cone, right? So when you have a triangle 2D shape and you revolve it around an axis, you get a cone. And then last but not least, if I have a axis, and it's either a circle or a semicircle. I'm going to just do a semicircle because it might be easier to show. What's going to happen here is when I revolve it, so again, this point stays put, this point stays put, but all of these points, and I use this one in the middle, rotates around and back, and we would just connect, and you can see that you get a sphere. So if you start with a circle or semicircle, so circle or semicircle, you're going to get a sphere. So again, a little bit of memorization today. Let's see if we can do these problems now. Okay. So the first one here, so we have a right hexagonal prism. Right, so again, make sure you understand the name. So it's a right hexagonal prism. We want to know the cross section that is formed when we go parallel to the base. So again, when we go parallel to the base, we are going to hit these edges here, 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 back here, back here. All 6 edges get hit when we go sideways. And again, it's going to go all the way around. That face, this face, that face, that face, that face, that face. And you can see that if you shade that in, you get a hexagon. This one's a little bit tough to see. So again, the shape of the base. So that was a hexagon. Okay, second one here. You have a cone. What type of cross section is formed when the figure is cut by a plane containing its altitude? That means through the very middle of it, the top, and is perpendicular to its base. Okay, so we're going to go through the top here, perpendicular, which means straight down. Again, it's going to touch the front, or the front of the bottom base, the back of that bottom base. We're going to connect. I'll shade it in just for effect, and you can see that this is a triangle. Perfect. Cross sections. Okay, next, I think solids of revolution. Now, Delta Math is a little bit more involved, solids of revolution, so let's do these. So it says match the 2D shape here with the solid formed by rotating around the region, right? Okay, so this is a rectangle. So hopefully you understand that the end result is going to involve a cylinder of some sort. So we're looking for a cylinder picture. Now the problem here is that there's this space between the rectangle and the axis. So notice that this space is a length of 3. So what's going to happen is when I rotate around this axis, this point is going to go over here, right? 3 away and come back around. That is going to be empty space. Same thing here, 3. That's empty space. But now this right here, right? We have 1, 2, 3, 4, 5, 6, 7. This length is 7. When this guy goes around, so 3, 4, 5, 6, 7, and comes back around, right? This is the solid space here, right? Same thing down here. We're going to go 7, 3, 4, 5, 6, 7, right? And I'll connect. So hopefully you can see that there's like this cylinder inside a cylinder, and this middle cylinder, this middle cylinder is hollow, right? So this inside one, I'm gonna put it in blue. This is the missing part. It's probably gonna make it look worse. Maybe not. Yeah, I mean, so you have a cylinder, right? I'm gonna actually delete that. That was not good. I can't. Sorry. So that part is missing, right? That's missing. The other thing they'll have you do is they'll have you identify this height, and this height is 1, 2, 3, 4, 5. So the height of this cylinder with the cylinder missing from the middle is 5. So keep an eye out for these dimensions, right? They'll put these, and typically the original dimensions are the radii of the circles you create, okay? And then you have a height. Okay, and then the last one. Okay, so now we have a triangle, but again, notice the triangle is away from the axis. So what's going to happen here is this point right here is going to go 3, and then 3 more, and then come back around. So there's that circle. This one here is going to go 3 down and 3 back around. There's that circle. That's going to be empty space. Then you have this point here, which is 1, 2, 3, 4, 5, 6, 7 away. It's going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, all the way out to here, and come back around. And we're going to connect. And again, what you have to notice is that it is this middle space. Again, I'm not going to draw that again. This middle space is the empty space. So let's see let's do the outside. So this, right? So that is the figure, right? It's this like, and again, it's going to be here too. It's like this like, I want to say trapezoidal, right? It's like a cone with the middle cut out and the top cut off. Hard to describe, right? But again, you have a radius here of 3. This radius right here is going to be 7. And then the height is from here to here, 1, 2, 3, 4, 5. So then that height, again, is 5. And I know the height's sideways, but that's still considered the height because it's from the bottom circle to the top circle. Okay? So again, do your best. If you have questions, let me know. All right, sorry again I'm absent. Make sure you take the 7-2 notes, the 2 videos, and we'll see you guys on Tuesday. Anybody that needs to finish their Unit 6 test, we'll do that on Tuesday. All right, thanks.